Hi everyone. Welcome to the video lesson for Wednesday, February 10th and Thursday, February 11th. If you were not in class today, you probably assume that you missed a checkpoint. Well, there is good news and bad news about that. It has been postponed until our Tuesday, Wednesday class of next week. The good news is I felt like you guys didn't get enough chances to really practice balancing in order to be tested on balancing now. The bad news is there's 5 days between this class and your next class. So it's very much on you to make sure you keep practicing until our next class so you don't come to class with no idea how to do this. So please, I know it's a long weekend. I know it's a holiday weekend. I hope everyone has a wonderful break, but you do need to keep practicing this so you know how to do this when you come back. To stay on the theme about balancing and getting more practice, that was our warm-up. Our warm-up today, I gave you C4H8 plus O2, yielding CO2 and H2O. This is the combustion reaction from slide 10 up. This is the combustion reaction from slide 10 of our homework. So I was hoping some eagle-eyed students might notice that and be able to do their warm-up and submit it in just a little bit faster. But I will show you the solution on how to solve it right now. So to begin, I'm going to start counting up all my different atoms and I'm going to make myself a chart. So I've got my reactants, I've got my products, and then my elements I'm using here are carbon, hydrogen, and oxygen. I know school is completely virtual right now, but having some pen and paper nearby is always a good idea to help you out. All right, so let's start counting our totals that we begin with. So on my reactant side, I'm going to start with 4 carbons. I'm starting with 8 hydrogens. And I'm starting with 2 oxygens. And I want to point out there's 2 different ways you can find out these totals. You can count the individual atoms, or you can look at your subscripts. Remember, those subscripts add together to get to your total number of each atom. All right, on my product side, I've got 1 carbon. I have 2 hydrogens. And then I have 2 plus 1 oxygen. So I've got 3 oxygens. It's always one of my favorite things for combustion reactions. Your starting products are always 1, 2, 3. So when I showed you how to do your homework slides, I did it one way. I just took and multiplied, added more of each molecule model. I'm going to also do this with math this time around so you can see how you can actually skip those molecules if you want to. So my first one I want to balance is my carbon. I have 4 on my reactant side and only 1 on my product side. So by making more molecules and writing a coefficient, remember, all you really need in your final answer is your coefficient. Your coefficient multiplies the subscript to get you your total. So if I only have 1 and I want to equal 4, something times 1 will equal 4 carbons. So that would be 4. So let me make 4 molecules of carbon dioxide. So here's 1, 2, 3, and 4. So now I have 4 molecules of carbon dioxide, which gives me 4 atoms of carbon dioxide. But changing my coefficient for carbon dioxide also affects my number of oxygens. So 4 times 2 means I now have 8 oxygens here, plus the one that's in water. So I had 3 oxygens. Now I have 9. So now my carbons are all balanced. My oxygens are not, but that's okay. We're going to come back and do that later. Let's focus on our hydrogens. So here I have 8 hydrogens. And on my product side, I have 2. So something times 2 is equal to 8. 8 divided by 2 is 4. So 4 times 2 will give me the 8 hydrogens that I need. And let's double check. 1, 2, 3, and 4. There we go. Got all 8 hydrogens. But 4 times 1 also means I now have 4 oxygens here. Let me count them up. I now have 8 hydrogens, and I have 2 times 4, so 8 plus 4 times 1, so 8 plus 4 gives me 12 oxygens. Now, this is the point in our example problem in our last class that we noticed this was not going to be very easy to solve because my number of oxygens on my product side was an odd number. Anytime you balance your carbons and your hydrogens and you end up with an odd number of oxygens, that means you're dealing with a very complicated combustion reaction. The solution to which is just double your balanced amounts of water, carbon dioxide, and your hydrocarbon. But here, I have 12 oxygens. So this is not a particularly hard combustion problem. All I need to do is divide 12 by 2. So 12 divided by 2 is 6. So my coefficient for O2 is going to be 6. And if I make 6 oxygen molecules, so 1, 2, 3, 4, 5, 6, I can see that I have 12 O2s there. So now I'm going to change this amount from 2 to 12, and I am good. I've got 4 and I've got 4. I have 8 hydrogens and 8 hydrogens, and I have 12 oxygens and 12 oxygens. The one last thing you need to do, if we were in person and you were writing this on a piece of paper, I would say this is great, you are finished. But since we're in virtual and you're about to have a quiz in Canvas, one last thing needs to happen. You need to put a 1 in front of your hydrocarbon. It's more correct to not write the 1. We are scientists, we don't want to be redundant. But since you are typing in your answers to a quiz, I do need you to type that 1 because if you skip it, it's just going to look like you forgot to answer one of the questions. After we went over the warm-up answer, I gave you guys a chance to ask for help on any of those homework questions. That Google Slide document, which was about balancing and reaction type, was due at the beginning of class today. But I know this was your first time, so I was open to going through any of the solutions. If we were in person, I grade homework every day. It's either there or else you get no credit, and I show you the answers in class. Since we're virtual, I can't quite show the answers, but if you come and see me during a student support session, I am more than happy to share the answers with you, as long as you've already handed yours in. So please remember that. Please come and see me. I've got nothing to do during those student support sessions. I'm lonely. Come say hi. After I answered a few questions about the homework, then we began our next homework assignment together, which was the PhET Conservation of Mass Lab. In class together, we went over the introduction simulation, all about N2 plus H2 yielding NH3. So to begin, we restated that the law of conservation of mass means that matter cannot be created or destroyed in a chemical reaction. All that we can do is rearrange our atoms. We're not creating atoms. We're not disappearing atoms. So we're given this example reaction. N2 plus H2 yields NH3. And we have a table. It shows that in my reactants, I have 2 nitrogens, and then I get 1 nitrogen as the product. And I start with 2 hydrogens in my reactants, and I end with 3 hydrogens as my products. So I asked the whole class as a whole, does this reaction, the way that it's currently written, follow the law of the conservation of mass? The answer is no. This does not conserve mass. I start with 2 nitrogens, and then one of my nitrogen atoms disappears because I'm left with only 1. And then I also start with 2 hydrogen atoms, but somehow in my products I end up with 3, so 1 appeared out of nowhere. This does not follow the conservation of mass. I cannot gain or lose atoms because of a chemical reaction. In your document, you have 2 different links to the PhET simulation. This is the type of simulation we used before we had access to gizmos. You're going to see the screen. There's 2 different options. There's introduction and there is game. You want to go to the introduction. And in class, I said, have some fun, play with this, find out what each different button does, and you should still do this on your own. When you were done, I told you to reset the whole thing and then go down to tools, and you can either use the balance beam or the bar graph. My personal favorite is I prefer the balance beam myself, and set everything at 1. So up arrow, and up arrow. So that gave me 1 molecule of each of the different molecules in this reaction. And then we started answering questions about what's going on here. So it asked which side needs more nitrogen, the reactant or the product side. Well, my reactant side has 2 atoms of nitrogen, and my product side only has 1. So the answer is the product side. So you were asked, without changing things to 0, because you can't have 0 of something, you can only have 1 or more, how can you change it so that the number of nitrogen atoms is equal on either side? Well, if I come over here, this is the side that needs more nitrogen. I'm going to increase the number of NH3 molecules. So if I give 1 more, oh, now my nitrogen is balanced. I start with 2 atoms, and now I'm ending with 2 atoms. So next, we were asked to look at the hydrogen. Which side of my reaction needs more hydrogen? I have 2 hydrogens on my reactant side, and I have 6 on my product side. So my reactant side is what needs more hydrogen. There's only one place I can get hydrogen here, and it asks, what can we change so that the number of hydrogen atoms on both sides is the same? Well, I can change my number of hydrogen molecules. I have 1. Now I have 2. Oh, not balanced yet. Let's do 3 and oh, look at that. It's happy. We balanced it. So now you just had to write down that balanced chemical equation in your paper. 1N2 plus 3H2 arrow 2NH3. If you have the time to subscript your subscripts, that would be lovely. Now it asks again, does this equation, written this way, follow the law of the conservation of mass? And the answer is yes, it does. I start and end with the same amount of nitrogen, and I start and I end with the same amount of hydrogen. No atoms were created or destroyed after the process of this reaction. So this satisfies that law. Then the next few questions are very simple, but a lot of students have trouble answering them because they are so simple. So the first question, how did the simulation allow you to change the coefficients in order to balance the equation? Well, in the simulation, we were able to add more of each molecule. As I add another NH3, that changes the coefficient to a 3. If I remove a nitrogen, that changes the coefficient again. So it allowed me to change the amount of molecules of each compound to change the coefficient. The next question is, does this simulation allow you to change the subscripts in the formulas? Why or why not? Now, again, this is a benefit that you guys are having with virtual school. A lot of students try to just add in some nitrogens by themselves on one side, or just a hydrogen atom by itself on the other side. You can't change subscripts. You can't just add on extra atoms. If you add different atoms, if you change the subscripts, you change the chemicals you're working with. You change the whole reaction, and you're now looking at a completely different reaction. You are no longer balancing the reaction you were asked to balance. So you can only change the coefficients. Changing the subscripts changes the compounds and changes the reactions. Often, if you're not careful, you might change the subscripts and make something that is impossible. After we finish this, number 7A asks you to balance the reaction of water separated into hydrogen and oxygen. And then 7B asks you about combusting methane. This has that graph right there at the top, those balance beams or the graph, and it will let you know when you have balanced your reaction. So make sure you write your final balanced reactions in your paper. Question 8 has you going to the game. So at the game, you have 3 different levels: your easiest, your intermediate, and then your much, much harder questions. Each level, it gives you 5 different chemical reactions to balance. It will give you a random one that it thinks is easy, medium, or hard. And you need to change those coefficients until you think you have a balanced reaction. If you get it wrong, it will let you know. You can try it again, or it will show you the correct answer. Of course, as your teacher, I hope that you try again until you get it correct. Once you have each finished correct answer, make sure you write it down in your homework. And it's going to be on your honor to report your final score for each of those 3 different levels. One quick warning I'm going to give you about these balancing games is in our Google Slides and in your checkpoint, I give you nice little images that show you which atoms you're dealing with. But in these, you don't always get those images quite as nicely. So if you have nitrate on both sides of an equation, in this balancing game, it will show you 1 nitrogen with 3 oxygens attached. In our Google Slides, if I had nitrate on both sides, I would not break that up for you. I would leave it as a nitrate on both sides. So you're going to have to determine, is it easier to just leave my polyatomic ion by itself and not break it apart? Or is it easier if I do break it apart? Am I going to be required to break it apart? Does it actually break apart over the course of this reaction? So you do have to make that consideration yourself. In your week 2 module, I have given you some more resources right here to give you more places to practice over this weekend. I have the Mr. Silber app. Mr. Silber has been so wonderful. He's made balancing and reaction type apps for you to use and to practice with. Now, this is not an assignment, but you can try your best. Remember, if it's a 1, you need to write it in. It'll show you your final answer. Make your guess as to what type of reaction it is. If you get it wrong, and make sure you click somewhere else. So if you get it wrong, it will let you know. If you simply balance it wrong, it will show you the correct answer so you can see how it's different from your answer. So see, that's the answer I gave, which was a 1 coefficient for each thing. The correct answer was 2 and then 1 and 1. So there's an easy mode and a harder mode to practice. We have a balancing act website. It's a game. It'll quiz you on about 5 or 10 balancing problems, and you can choose different difficulty levels. You can work with easy ones or more challenging ones. And then I found another teacher's blog that actually has a practice quiz generator. You can choose how many you want to balance. If you only want to balance, if you only want to identify, or you can do both. There is no way to choose your level in these questions, so some of these might actually be pretty hard, but it's a way to do it. I don't care what form you use to try and practice this weekend. I just ask, please do 2 a day. Find 2 problems from any of these sources and balance them. It's kind of like anything you learn in math or like riding a bicycle. The more you practice, the better you will get at balancing reactions. But until you put in that time and that practice, it's going to be kind of hard. I'm also going to try and make another Google Slide document soon that will look a lot like your homework that was due today. So you can have some more hands-on practice with balancing reactions. So you need to finish that PhET worksheet on your own this weekend. That is the homework you're being graded on. The homework that you are not being graded on is that you should still do another 2 problems each day until I see you guys again, so you're ready for your checkpoint. Also, make someone's day this Sunday, send out a Valentine. I'm going to have these images up in our module shortly, so you can just download it, send it an email, let someone know you care. And I hope you guys also have a lovely Lunar New Year and a very patriotic President's Day. And until I see you guys again, stay safe and make good choices, guys.